Okay, rubber industry tech talk. In this one, our focus of this episode is rubber testing laboratory automation. I think all of us know about the importance of the automation. Rubber testing is one area that we need to look at the optimizing the possibilities. We have two solution providers. Mr. Khalid Bokali is the CEO of the Labs Cubed, who offers the solutions for how to automate the rubber laboratory testing facility. And we have Mr. Richard Garcia. He'll be speaking about how to manage the data, R&D data, by using the software solution with Uncountable. And we also have two panelists who are well-known, well-respected, with huge experience. Dr. Barun Samoy is working with the Hasetri Harisinghania Tire Testing Research Institute based in India. He has more than 30 years experience in the R&D, materials testing, product development related to the tire and non-tire. And we have Dr. Brendan Rogers from USA. He is also a veteran in the rubber industry. He wrote very famous books in the rubber compounding and also tire engineering. He has more than 40 years experience in the rubber compounding, product development, and various issues. So what is the schedule today is that first we will have a presentations, and then after that we'll have in detail discussion about the rubber testing laboratory automation. So let me invite our first speaker for this one, Mr. Khalid Bokali. He's the CEO of the Labs Cubed. We'll be speaking on the lab of the future in the rubber industry.
Right. Hello, everyone. Can you hear me? Are we good?
Good. Proceed.
Screen is good. All right. Hi, everyone. Thank you for the invite and for the great introduction. So I'm going to jump right in talking about laboratory automation and who the heck we are and what we do as well. So a little bit about myself. So my name is Khalid. We're a company and we're located up here in Canada, just outside Toronto. I did my master's in mechanical engineering, and my main thesis was around material development. So we were working on new adhesives actually for the automotive industry. And what we found, or what I found at least, is I sat in a lab doing a lot of testing and a lot of characterization of different compounds. And so it was very manual testing. And I really hated it after a while. But I also realized that making materials is a really difficult, long process, whatever material you're making. And so we started a company around that thesis, which is that if we can improve the way that materials are made and speed up that process, we can really help to change the world in a better way. And so that's the main reason that we started the company. We started it about 6 years ago, just to give everyone a bit of a reference. So in terms of agenda, we'll talk a little bit about Labs Cubed, what we've built, and some research behind what we've done to date. Then we'll talk a little bit more about what is automation and AI for labs, what is it, how does it work? And I know you guys will hear a little bit more on the data side and the software side from Uncountable. We have a great platform. And then lastly, we'll talk about how to prepare your lab for Industry 4.0, that concept around full automation, and this really cool thing called a map, which I'll kind of explain near the end as well. So a little bit about ourselves. We build actual hardware that goes into labs to automate testing. Specifically in the rubber industry, it's tensile testing, tear testing. And our goal is very simple. It's to make really easy to use, affordable testing in a box. So you don't have to kind of retrain your team. You don't have to change the way you do anything. These systems that we've built are literally plug and play. You place them on a table, you plug them in. It takes about 15 minutes to train a technician. And then from that point on, every one of your technicians will get great data every single time. And we have this hardware. So the easiest to do here to show you a quick video. I know it's a bit jumpy because of the way videos work on here, but essentially with our machine, you can put in tensile tear samples, ISO, ASTM, JIS samples into a tray, put the tray into the machine, press start, and then it'll automatically load each sample, test each sample. We have really sophisticated vision systems and sensors to kind of collect a lot of data and metadata, which is really important for future development, for future work that will be done with that data. And essentially you pull, you break, the same thing that your technicians are doing every day, we're just automating it and making it really attainable for everyone in every lab. In terms of the hardware itself, automated tensile tear testing, like I said, ASTM ISO, calibrated and certified those standards. We have customers that have extremely high accredited labs, like Bridgestone, for example, is one of our customers, Airboss. They're using it both production and R&D side of things. So we are fully certified. The product has been out there for over 2 years now, running it full. Some customers running it for 3 shifts a day. We have kind of a lineup for machines. So we have a smaller machine that's able to do less samples, really for R&D, where you're trying to get really high consistency, but your volume isn't as much of an issue, but automation still has that benefit. And then for somewhere automation, the benefit really is that they need to just run through as many samples as possible from a production point of view. So it's really easy, really fast to use. We use video for a whole bunch of things. I mean, most people today can still use video for elongation, but we use it to actually analyze good or bad breaks, coloration, a whole bunch of other things as well. So I think one of the most important things when you think about automation in a lab is how does it actually improve consistency or the data output that gets created? So we've done a really large consistency study, and we continue to do it with customers. Every single time new customers come along, we kind of do this. So we do it by trying to control as many variables as possible. So we run control samples that we create, that we have. We randomize the sample selection. So once we stamp out, let's say, a whole bunch of samples from a huge sheet of rubber, we randomize that so nobody's getting like certain batches. We cut out the samples, we measure the thickness, we measure the width, and then send out these materials to different companies, and they run both on their manual system, so their technicians actually running on a conventional tensile machine, and then we run an automated fashion, and we do a comparison to show that consistency potential increase that should exist. We've run thousands of samples doing this, so it's quite a large study that we've done across the board. And essentially what we found is, as you would guess, consistency and your coefficient of variation gets better as you use automation versus manual. And we've seen this not just with tensile testing, we've also played around with customers who have like automated rheology systems and different systems that are also automated hardness. And it does exactly the same thing, plus or minus. And it's not a small increase. I mean, for most customers, we're finding around 40% is the average increase in consistency that you get in a batch, for example. And that can be really important from an R&D perspective. So you obviously want to make sure that when you're doing R&D, you're getting the best data and you're doing it quickly, and you don't have to test a ton of samples. You can test less samples and still get really accurate data. And from production, it's really important because it can start to tell you when there's issues earlier, because you know that your coefficient of variation is very low when you use automation. And so anytime that kind of starts to get away from that, you can kind of find those issues earlier. So this consistency results can be really important across the board. In terms of accuracy, we've done accuracy studies as well. Obviously, once you introduce a new product and a new machine and a slightly different way of doing things, people want to know, is it accurate? We participated in a study where it was, over 100 labs. They get sent out samples from the centralized system, and the samples are then tested by all of us autonomously. We don't know what the data is. We send the data back in, and then they show us this graph at the end to show where we're at. So you can see for the left-hand side, our stress pretty much bang on compared to the average of where all the labs are. Our strain's a bit higher, as you would expect, because we're using a vision extensometer and not a physical extensometer. So we're very accurate and yet that much more consistent than what exists out there. Benefits of automation generally is time saved, obviously. Your technicians are no longer sitting there doing that thing over and over. On average, we find it's about 85% of your technician time is saved. There's still some aspects to setting up samples and going through certain parts, but really the majority of what they do is no longer sitting there testing one at a time, as you probably see people doing all the time. Consistency is a big one. You're increasing up to 40% more consistent, which I think is a really big, very important point, especially when people start to consider wanting to use their data that they're producing in their labs for AI systems, for prediction capabilities in the future. And we'll kind of talk a little bit about this in a bit. That becomes really important. Oh, and then lastly, I think a couple of very interesting points we found as we go along. There's cleaning backlogs. So obviously customers now, they have technicians that have time, so they can clear out their backlogs, speed up the process when it comes to R&D, which I think is very important. A sales tool. So once you show that you're bringing in automation and new technology, your customers will see that. And I think that's usually a very positive sign that things are moving forward, that your company is moving forward. Last one is attracting young talent. I think that's really important to bring in, and I hear this all the time from everybody in the rubber industry that it's a very difficult thing to attract young talent into our industry, into the rubber industry. It's not sexy enough, I guess. But I think this is the way you do it. You show them that we in the rubber industry are implementing new technologies. We're implementing the future, and that their future in the rubber industry means that they can actually use these tools that are important to them. So quickly about automation. I'm not going to talk about robotics and systems. I think we've all seen them. You'll see them in manufacturing. You see them everywhere. But the main thing I always ask people when they come to us to talk about automation in their labs is, do you have tasks that your employees are currently doing that are repetitive, that are a bottleneck, slowing things down, that have human error associated with them, that you have to retrain people? When you have to hire a new technician, it takes a really long time to train them to get really good data. If your answer is yes, then that's something you should be looking at automating in some way or another. Now, it might be that it's prohibitive, it's too expensive to automate. There's a whole bunch of different reasons not to do it, but it's still important to start looking out there and seeing what's out there, because one day someone comes along and creates something innovative that solves your problem. So I think that's kind of the main question that I always ask people. The other thing I want to say is not all tests can be automated. I've been in labs where there are tests that are really technician driven, require a lot of knowledge, and are very difficult to automate. In those cases, those might be something really for the future, but that's the main question that I ask when I talk about automation with customers in terms of hardware itself. So talking about artificial intelligence is the other piece of it. Generally speaking, artificial intelligence systems are systems that predict algorithms. I think a lot of people kind of convolute and make AI really complicated. Everyone talks about it, but the best thing that anyone's ever described for me is that you replace the word AI with the word prediction, and it's pretty much what someone's trying to sell you. If they're trying to sell you an AI system, essentially they're telling you, I can predict things better than you can, faster than you can, in theory, using this software. The concept of AI was introduced a long time ago, back in the 1950s. So it really begs the question, kind of, why did it start in 1950 and only become so big today? And there's two reasons. Number one, today we have a huge amount of data that we're creating, clean data, good data that's actually digitized. I think that's another one. A lot of you will know from your own experiences or knowing from customers, a lot of data that they have that's historic is sitting in files, literally in folders, in shelves, or they're sitting as a scanned piece of paper or something, where it's really hard to kind of digitize it and read it. But today, all that data is kind of being digitized through our phones, through our laptops. You guys all create Excel sheets all the time. And so I think a lot of data, because it's really important to AI, is being created. The second thing is the cost of prediction has gone down. So every time you have to crunch through data, there's a cost to that. It used to be that you'd need to use supercomputers to do it, but today your phone does it, your laptop does it. So you put those two things together, lots of data, and it's really cheap to do stuff with it, and you get a whole bunch of AI in all parts of our lives. One quick example that I kind of usually try to get into, just to give an example, anytime you hear machine learning or neural networks or any of those other words, essentially they're all AI systems that are trying to predict things using different ways of doing it. One common one is supervised machine learning. So in this case, the example is you're giving the model pictures of apples and you're telling it it's apples. And then the model learns about all the apples in the world. And then one day you feed it a random picture of an apple and it should predict, hey, that's an apple. And that's a prediction model. And as you can see, it's very important that known good data goes in. If we fed it pictures of oranges and we told them those oranges are apples, it would predict incorrectly. So it's all about that good known data. And that's a big part of this, is clean, good data is the most important thing. If you feed really bad data into any model, I don't care how great it is, it's still going to give you a bad prediction. So the data and what you're producing is really important. Hence why, as you automate, you get better, more consistent data that becomes, your model becomes much more powerful and much better at prediction. So clean data. Clean data is organized, it's traceable in the same format, hopefully in a cloud-based system, so you can do stuff with it in the future. And I think that's a really important part of it as well. So for example, if you're looking at an Excel sheet and numbers are randomly placed all over the Excel sheet and there's no headers and there's no information connecting anything, you wouldn't be able to make sense of it, and neither would a computer. So that's kind of how I think about it when I think of clean data, as the simplest way to kind of think about it. But that's why when you automate, again, in labs and you automate your production and your manufacturing, you're actually collecting really good, clean data that you're then able to use in the future to create really smart plants and labs. I'll give you a couple of examples because of the automation that we've implemented in our systems. And we collect a lot of data that you see, obviously, the stress strain curves, and we create a whole bunch of, the moduluses and all the normal information. But we also collect data on all the sensors, all the motors, how the cameras are recording, the discolorations that might occur in the samples. All that data is being collected and saved. And from that, we've played around a little bit. We were, for example, able to predict the hardness of samples. We don't have a durometer in the machine, but we're within 1% accuracy of predicting hardness of the samples that are run in our system because of all the great clean data that we collect. We can predict good and bad breaks. Before the sample breaks, we can actually tell within a 95% accuracy if it's a good or bad break. And that's getting better and better as the system keeps learning and learning. So there's endless things you can do in the future, but as long as you kind of build a really good system for collecting really good data, the possibilities are endless as you grow. So let's put it all together, which is Industry 4.0 or the lab of the future kind of concept. So everyone thinks of Industry 4.0 as kind of the computers and robotics, but it really isn't. It's kind of taking computers and robotics and giving them an intelligent layer, meaning they can make decisions. So a quick example is, let's say, a fully automated manufacturing plant that takes into account the humidity and temperatures and maybe final testing in the quality lab to change the mix or change slightly the ingredients that are going in to keep getting really consistent, great output material. That's where you get to Industry 4.0. So what can you do today to kind of start moving in that direction? I think there's two major things that you need to think about. One is increasing automation in labs, because we're talking about labs today. Production is already improving every single day and ramping up. But if you can increase your automation in labs today, that's a huge step forward. And that can be anything. It doesn't have to be what we have. There's other offerings out there that might be more important to you. Maybe hardness is more important. Maybe the rheology data is more important. Whatever is important to you, look at that and see if there's potential to automate. The second thing is improving your data collection. We see pretty kind of sporadic data collection where each system might save into a place. There's still Excel sheets where people are kind of doing very interesting things. There's still papers where people write things on them and then they scan them in. You got to improve all those and really try to digitize and clean up that process as much as possible. Centralize it if possible into a cloud system. I know there's a lot about security when it comes to cloud, but the reason for the cloud system is it really allows you to kind of have that data ready for the future use, whether it's porting it in for other companies to help you out with AI systems or whatever it is. That could be a huge step forward. And lastly, connect as many machines as you can to kind of a very centralized system. I think a lot of companies we walk into are still using kind of systems where each one is on its own, and then they collect the data and they put it in themselves. The faster you can speed up that process and the smoother you can make that process, the better the whole system becomes in terms of Industry 4.0. We think it's kind of a multi-stage process that most customers that we've seen go through that are more successful. So we find that the first step is looking at some form of automation in the labs so that you can start that clean collection data process, along with thinking about a software that you can plug in for that data to go into, whether it's Uncountable or clean software, whatever, your own LIMS system that can go cloud-based and might have a great way of doing it. So that's stage one, and it could be any automation, really. Again, it doesn't have to be just whatever we're creating. It could be, there's other great automation out there from other companies. And if you guys need any suggestions for anything that you do every day that you want to automate, please feel free to reach out. We're kind of connected to a lot of companies that do great other automation. So that's stage one. Stage two is starting to connect everything through, whether through our system or other systems that you already have that you can implement even faster. That's even better. Encrypt, secure the data, but make sure it's all kind of in the same format, clean, digitized. And then stage three is where you start to reap the final rewards, being that you can use AI, you can use machine learning, you can use some form to start better predictions and speed up your process and move towards this concept of a map. Now, we're getting close to the end here. So maps, this is an amazing new concept. It's called a material acceleration platform. And the goal is to combine essentially everything we've talked about to speed up the process of creating materials to a different level. So imagine a lab where it can mix the materials on its own, it can test the materials on its own, puts that data into an AI system, figures out what to mix next, and keeps going until it creates the perfect material. So let's say a customer comes along and wants to change the properties or wants new properties. Or today, sustainability being a big thing that we're all pushing for, we need to create really sustainable rubbers and materials. Well, we got to test a lot of ingredients, and we got to test how they combine and the final results a lot to get a really good sustainable material that's also a great material for customers. So you could do that using these fully automated labs. And it might seem like it's very academic, but it really isn't. It has been done out in industry in different places, not as much in rubber, but in other industries. And the results are absolutely amazing. So here's a map example where they did one for light stability. Essentially, it was chosen where they looked at a development that had already occurred in the past, and it took over 1,000 iterations, and it took years of development to create something that they needed and then were able to sell. And what they did is they created a full map to kind of do the same thing, to show the benefits and how much faster it could be using a map system, a fully automated lab, versus our conventional methods that we do today. And the results were amazing. It went from years to weeks of development time. And if you can only imagine, anytime your ingredients change, maybe you have the supply chain issues and you have to change an ingredient. Again, maybe the sustainability, you're pushing for brand new sustainable materials. Those companies that jump on this and start utilizing it and start implementing it correctly today will be able to make huge changes and have a huge competitive advantage when it comes to moving to the future. So this is kind of where it all comes together. When you take the automation, when you take the AI, and when you start creating these really amazing smart labs, you can take things to a different level when it comes to both development, but also in the quality and production point of view. I think that's all I got. Thank you so much, everyone. Here are some of our details. If anybody has any questions, would like to reach out. If you want to hear about other systems that we know of, both from the automation or software side, please feel free to reach out. I'd love to give you guys connections as well. Thank you so much.
Thank you, Khaled. Yes, that's a presentation on the lab of the future in the rubber industry by Khaled. If you have any questions to Khaled, you can post your questions in the question box. We'll be discussing these questions in the last part of the today's session. Okay, Khaled, please stand by. Okay, thank you very much. Okay, now I invite Mr. Richard Garcia. He's the Director of the Sales for the Uncountable, and he'll be discussing about the modern R&D data management, the benefits of a cutting-edge software solution.
Hi everybody, how are you doing today? I'm going to start sharing my screen, run through a bit of content here, and yeah, looking forward to today. So going to start off with just a brief intro to Uncountable as a company, then going to discuss the status quo. So what do we typically see in terms of data structure in R&D organizations, and then talk about the solution that would be of benefit to all R&D organizations. But if we were to start from the top and just give you a background to us as a company, we can go ahead and go from there. So Uncountable's been around for about 6 years now and are spread across a few offices, with myself located in the San Francisco branch. Currently working with over 50, I believe actually over 60 customers today from a lot of different industries, some of which listed on the left, others conveyed by the logos on the right, probably the ones you're most familiar with in the similar industry: Cooper Standard, Airbus, natural fiber welding, but quite clear that some of these industries are quite different from one another. The one similarity that we happen to see across all of these teams, prior to working with Uncountable, was a similar challenge that we see across all of these R&D organizations. And it's this challenge of putting their data in a workable and centralized format, and because of that, not having the best opportunity to use this data for current and future developmental work. So what we have and what we present to all of these different R&D organizations is this all-in-one R&D software solution that, with this larger suite of tools, helps reduce experiments and overall development time. But before we get into how that happens, I want to discuss a little bit about the status quo amongst R&D organizations, of course, that of which in the rubber industry as well. So the problem we're specifically addressing here at Uncountable is this problem of unstructured, decentralized data being the biggest barrier to efficient and innovative product development work. And reason being is because we find that R&D organizations are amassing a lot of data from a multitude of tools, whether or not these are LIMS solutions, whether or not they're ELNs, process historians, ERPs, or spreadsheets. All this data is spread all across an organization, and it resides in what we think of as separate buckets. And we say buckets because the data is disconnected for a couple pretty obvious reasons. First of which is that these systems are not compatible. And then second, when we talk about the most commonly used tool across all these teams, spreadsheets, we're talking about a lot of unstructured data. So we find that there's a lot of untapped potential, a lot of untapped insights that teams are completely missing from having these disjointed systems and heterogeneous data sources. So I name dropped a few of these systems just to reiterate what we commonly see across teams, spreadsheets being the #1 thing used across all different teams, using DOEs, using LIMS systems, using lab notebooks, like I said, traditional electronic lab notebooks or the physical lab notebook. The status amongst ways of teams collecting data today has not really changed over the last few decades. And the other, call it, driver complexity that comes into the way data is collected today is not only the different tools that are used, is the fact that these tools are different across all of these teams. So for instance, you have an R&D organization that has 2 separate chemistry areas, and maybe within each individual chemistry area, we're talking about labs in different areas. Maybe one in the US, maybe one in Germany, and maybe the third in Japan. All of these different groups across the R&D organization are commonly using different tools. Like I said, different LIMS solutions, different ways to collect data, whether or not they are throwing it into a hard drive, throwing it into a SharePoint, with no good real central way to collect all of that organizational know-how. So we're going to jump right into the solution. And what I want to start off with is just a little bit about Uncountable. So the reason why we find ourselves as the solution to the problem today first kind of touches on the fact that we are a trusted partner in the industry. We do have a lot of customers willing to talk or to attest on our behalf, whether or not they are from a 3D printing company like Carbon, where they do recognize us helping them accelerate development and helping them solve or speed up the solving of these complex problems they're working with, or enabling collaboration. As you know, if your counterparts are working on the same technology but across the seas, you don't really have the best opportunity to, say, talk with them, learn about what they are actually working on in real time, or actually collaborate with your peers, maybe across the pond. So enabling collaboration. And lastly, which we're going to focus on today, is connecting all the dots of your data. So this leads into an increase in efficiency that's attributed to the fact of this disparate data problem. And with a system like Uncountable being able to connect all the dots, analysis, reporting, or just overall learning that is kind of bogged down in this data curation or data collection or preparation process goes from hours or days just to a matter of minutes. So what Uncountable acts as is this all-in-one R&D software solution. But what makes us different across or versus traditional solutions is that everything within the system in Uncountable revolves around this formula and property database. So think about all the information that goes into an experiment. We have your formulation, we have ingredients, we have process parameters on one side of things. And on the flip side of things, we have your corresponding measurements. But as you add in any additional layer of complexity, maybe we're talking about a complex experimental workflow. Maybe we're talking about a part A, part B mixture. Maybe we're talking about some ingredient attributes or some stoichiometric ratio you need to keep in mind, or some cost variable that you need to keep in mind. And on the flip side of things, maybe we're not only talking about a test, but we're talking about a test and at some condition like aging time and aging temp. What's unique about Uncountable is that as you add in these different layers of complexity, it's always automatically interconnected within the Uncountable platform. And what you might see that's done in some systems today, it's typically done for maybe a production formulation and the corresponding physical properties. But within Uncountable, we're taking all of that research data, all of these different iterations that are required for you to reach a production formulation, connecting it and structuring it so it's made available to a team. Now, we do have quite a comprehensive solution, but we give teams the opportunity to pick and choose what's most appropriate for them. And then also connecting to existing software streams today with a goal of mind of contributing to the build of a data infrastructure that we find is necessary to not only maximize resources amongst the R&D team, but also quite critical in unearthing insights that we find help accelerate development. So, like I said a second ago, is that the system is intended to fit in the middle of your digital ecosystem. As you know, companies in the rubber industry, they've been operating for quite some time. And for us to come in and say, hey, you need to rip everything out and use Uncountable for everything across the board would be an unrealistic ask. So what we commonly find ourselves doing is connecting to whatever existing data streams that the teams want to continue to use today. Whether or not it is ERP, say SAP or Oracle, where they want us to pull in their most up-to-date ingredient cost information. But they want us to push back out production formulations, very common workflow done today. Or maybe some organizations have an existing LIMS solution, and the LIMS solution is so ingrained in their operations and maybe used across their global operations, it doesn't make sense to rip it out from today. It's completely fine. What we do is we allow for us to connect to that today, so we can pull in your results from your tests and connect it to the corresponding formulation. But the fact of the matter is that we do want to play well with other software solutions, because we know that everybody's current situation is different from organization to organization. Now, Uncountable facilitates horizontal communication between teams working on the same applications. This means that you have a team in the US, you have a team in Germany, you have a team in Japan working on the same technology, but also want to benefit from the learnings from each individual team. So if we have a centralized and kind of collaborative data environment that teams can pick and pull from, they don't find themselves doing duplicate work or find themselves not kind of benefiting from things that have already been done in the past. But not also horizontal communication, but also vertical communication between teams. Maybe if you're a larger rubber organization and you have a team that is synthesizing a polymer, and maybe you have another team that's using this polymer in some sort of application development. What we have on the platform is this hierarchy, so you can use the output from one group, this polymer, as the input from another group, this applications team. And this is all attributed to this data standardization model that allows for a similar kind of format across all different teams and an entry of data that is quite similar and seamless to use, so that it can be flexible and work for these teams working on different technologies. Now, an example of what that might look like is where we have a intermediate, so this blend or this mixture, as a subcomponent in your actual formulation. And you can see if you just click into a drop down here, you could see the composition of that subcomponent as an example of these connected experiments. But not only are you able to see in a tabular view as you're actually working on formulations, you can also see it in this process flowchart view of the world. So you can see where these subcomponents are used throughout further downstream formulations. Another way that Uncountable helps standardization is through recording the results of your tests. So this is a good example here, because if you think about a traditional LIMS solution, a traditional LIMS solution is going to take this particular test and probably have it in a free text format. Stability, 23 degrees C over aging time of 2 weeks using this method B. Within the Uncountable platform, we do create these as separate conditions for your test, so that we can actually have these as different values here: 23 degrees C, 2 weeks, method B. And the true benefit here not only comes from from the actual structure that I'm showing off here, is from searchability. So I can actually search for all my stability results at 23 degrees C, but also in the analysis of your data. So that because you are collecting it in a structured manner, you're able to learn and dissect the data, being that you are collecting it in a very clean manner. This is just an example here of the searching capability of it, being that you were able to kind of create that condition of aging temp so that your results do show, or in this case, stability at everything above 50 or everything above 75 done at 50 degrees C. Also, another standardization example, a benefit of structuring your data like that is that you're able to do things like, for instance, calculate a viscosity change automatically, because we could see that in this case, we have viscosity done at 100 degrees C at an aging time interval of 0 weeks and 2 weeks, automatically computing a thing like viscosity change, being that we are collecting your data in a structured manner. So the same kind of calculations you see on your static Excel sheets are done consistently across the platform. But along with the collection of your data, everybody always asks, what is the actually added benefit of having your data structured in the system? And I hate to go back to a previous slide here, but it's pretty clear. So accelerating development, enabling collaboration, increasing efficiency when you're trying to analyze or learn from your data, but also the cherry on top, which I can which talked about in the prior presentation, is machine learning. So what we have in the Uncountable platform are built-in predictive tools that are able to feed from this wealth of organizational know-how that you guys have collected. So what the Uncountable system is doing is, by teams doing their day-to-day lab work, working on new formulations, recording the results of your tests, creating lab requests, and having everybody collaborate in this tool, everybody is inadvertently adding to their machine learning models' understanding of their own formulating space. So you're able to do things like on this slide right here, being able to have the system suggest a formulation that is most suitable for you to achieve some desired performance characteristics. And here's another graphic right here, not only being able to have it suggest formulations, but being able to learn. Maybe in this case, looking at a surface plot and understanding the relationship of two inputs towards one of your key properties. Or on the right-hand side, being able to predict the performance of one of your formulations based on prior data. So think of this as the cherry on top, but you can't have one without the other. The reason I show this as the last piece of the presentation is because the first problem that needs to be solved is, how do we get everybody collaborating in a single source of data entry? How do we get people out of spreadsheets? And how do we get everybody to, like I said, attribute to their companies or their organizations' machine learning models' understanding of their formulating space? But that does include everything I have prepared for today. Thank you for your time.
Thank you, Richard, for introducing about this R&D data management. Okay, now we invite all the speakers as well as the panelists, Dr. Barun Samoy, Dr. Brendan Rogers, Mr. Khaled, Richard. Please join us for the discussion. Everything about rubber testing laboratory automation, please. Please open your cameras. Okay, Mr. Dr. Samoy. Okay. Dr. Brendan. Okay, he'll be joining us in a bit. Okay, let's get started. Let me give you some ground rules for this panel discussion. This is a informal coffee table conversation, guys. Okay, and you can ask questions each other. And as I mentioned to you, Dr. Varun Samui is well-experienced rubber technologist with more than 35 years experience, and he knows ins and outs. 30, okay, 30 years.
35, yeah.
Okay. 30 plus years. He knows in and out of the the rubber testing. So Dr. Varun, we'd like to start with some of the discussion points with these gentlemen, Khaled and Richard. Yeah, please.
Sure. I listened to both their presentations quite attentively. So I means our company, that Hasitri, could be one of the potential customers of those both Khalid as well as Richard. So first to Khalid, when you talk about automated testings, you showed a box, right, where you are showing those dumbbells putting into these things. So first, my basic questions is, so for example, I'm considering myself as a potential customer. So I'm asking how that can be integrated in my machines which are already having UTM, which may be a Zwick already. So can you just explain this part?
Sure, yeah. So it really depends on some labs will, for example, use their UTM to do a plethora of other tests, peel tests, whatever, trouser tear, whatever it is. But what we find is our machine just replaces a UTS machine, a Zwick machine. From an R&D perspective, it sits on the table, the other machine kind of gets put away, and they use our machine as the main one for all their tensile and tear testing. From production, that's kind of the main thing. The goal is, for production, they're usually doing some kind of rheology or something, and tensile testing is their main two tests at the end of the line. So our machine just replaces their current manual Zwick or Instron or whatever testing machine that customers use every day.
So that means you are aiming for a production kind of a machine's QA laboratory, not an R&D kind of a setup for this you're offering?
No, so our current customers, like I think Richard and I, we both have like Airboss, for example, we have Bridgestone, we have a lot of other companies, they put it in both. So they end up buying so we have a light machine for R&D, and they're putting it there to increase, speed up the process, but also get much better data results, more consistent results. And then for production, it's just purely a time saving, right? So it just saves a lot of time and money. And so it's that return on investment. So we find both customers are buying for both sides.
So your product, when you say it is which UTM, for example, your product, if had to integrate it with which UTM, you have to buy a new UTM for that along with your product?
No. Our product is a UTM. Like inside of the machine, it's a fully enclosed system. You're buying the whole thing as part of our machine. There's nothing else. This isn't an add-on onto something. It is itself an automated UTM.
Okay. So what is the name of that equipment when you say tensile machine? So that you have not shown in your presentations. So, your presentation should be look like all those customers, right? So they will be talking about first thing, first big questions. What is that UTM which you are going to have? In rubber industry, as you know, that Zwick and Instron as the two big players. So it is which machine, which brand, the tensile machines?
Our own. We built it from the ground up. So
what is the name?
LabsCube. So it's our own machine from LabsCube. We use like the load cell comes from Omega, so it's a high-end Omega load cell, for example. But essentially, we've taken a UTM concept and automate and simplified it so we can automate around it. But it's our own machine. We're not taking an Instron, we're not taking a Zwick and modifying it. We've built the machine from the ground up as a fully automated UTM. Yeah.
Okay, good. Rather, I'll give my email ID to you. You can send. So I'll look into that. What kind of things you are providing.
For sure.
That's one. Second point is, are you talking about only UTM? or any other things?
Right now, UTM, we're very, very concentrated on just tensile tear testing in terms of high volume for customers.
Oh, this is for the high volume, only for the UTMs. You talked about rheological properties also, right? So you don't have right now.
No, we don't. But honestly, Alpha and Montech and some other rheology systems, they have automated systems. I don't know how expensive they are, but they do have they have good automated systems. Yeah.
No, we have couple of Alpha systems.
Yeah.
We have Montech system also in our plants. In R&D, we have mostly Alpha, who is the global leader today.
Yeah, they're a great company. They're an absolutely great company. I mean, we work with them on some labs because they don't sell tensile. We work with them and we sell our machine and they sell theirs to kind of try to retrofit labs today.
Okay. Good. So when you look into an R&D perspective, you correct me if my understanding is right or wrong. When you look into the R&D labs perspective, it not the volume, hundreds of samples doing in 1 hour kind of a thing. You need to look into a whole lot of other things also. When a sample is breaking, what kind of even ruptures happening into it. Then you need to do in a group of say 5, where 5 observations are there for a particular set of samples, and then another set of samples. You need to look into immediately also, after those tests, what kind of standard deviations and variations are coming. So I got your point. So primarily your focus is on the production high volume UTM at this moment. Is my understanding correct?
Yeah, so I find that that's kind of like the clearest, the return on the investment of why it makes sense to put it in today. But weirdly, a lot of our customers buy it also for R&D, like I said, and it's that one's more about consistency. If you really want to increase the consistency, and also what we're finding, at least in North America, I don't know if it's actually different. I'd ask you the same in India, but and around the world. But in North America, there's a shortage of technicians and people actually running in labs, so they have to automate. It's not really a question of, oh, do I want to? It's they don't have enough technicians doing the testing.
Okay.
So we find they're buying both for R&D and production because of that as well. There's just a shortage of people.
Yeah. Why I said R&D? R&D actually, even for the UTM, it is not just only dumbbell tensile.
Yeah.
Even within dumbbell, there are non-routine kind of tests are there. It is not just only regular tensile tests. There are hyper-elastic tests are there, right? There are many other kinds of tests are also there. So your machines, which your systems is offering only for the kind of a routine regular tests or non-routine research developments kinds of tests also.
Some non-routine. It really depends on what the non-routine is. Like we can do swell tests, for example, but not, some swell tests are like 100% swell. You can't really do much with that. That's really hard to deal with. So there's some non-routine. What we find with customers is they'll buy our system in their R&D lab and they'll put it beside their UTM and then keep the UTM or their old system for those weird tests that they do once a month or very less frequently than the normal tensile tests, for example.
Does it come with environmental chamber also?
No environmental chamber, no. We get asked that a lot actually because it looks enclosed, right?
Yeah.
So it looks like it can do it, but no environmental chamber.
How big is the, do you have very flexible kind of, or what kind of load cells you are offering in these machines?
The load cell is a 1 kilonewton load cell. We can go down and a bit up to 2 kilonewtons, but we find 1 kilonewton, or what is that, 250 pounds? That's more than enough for everyone that we've seen in rubber, and we've never had an issue with that in rubber.
Okay, not like 5K or 10K like that. Maximum 2.
Yeah. Do you guys, like, from your lab, for example, do you use a 5K or 10K?
We have 10K also because our UTM is not just only for rubber testing.
Yeah.
It has flexible, like even reinforcement testings, adhesion testings of tire, of all those things.
Oh yeah, that's a very different thing for sure. Yeah.
Because UTM as such is a big investment. So when we will be buying, we need to buy a machines having lots of flexibility into it.
Yeah, makes sense.
So that's it. We have even multiple 10K in load cell machines.
Yeah, yeah, and that makes sense when you get into reinforced materials and like you said, because you guys are also probably doing tire testing and some other things that are very different.
Exactly.
Yeah.
Exactly. And this machine comes with extensometers, optical extensometers, your machines.
Yeah, optical extensometers. Yeah.
Okay. Okay, it's pretty clear. So you are coming up. How the, by the way, how the response from your customers? Who, for the audience benefit, you can also tell about customers space. Which type of customers are there? Is it only the rubber? I mean the tire companies or other non-rubber manufacturers also, like those things?
Yeah, so we have tire companies. I mean, the only one I can talk about for now is Bridgestone, but they're using it from an R&D perspective, for example. So they put it in their R&D plant, and pretty similar to what you're saying, they have, I don't know, probably like 7 other UTMs that are doing different things. And they're using ours just for high volume, consistent comparison results as well. So they put that in. Airboss, similar, so R&D and now moving on. So they bought first for R&D and now they're moving on to production and putting it in production. We have Saucy up here. So they're using it in full production. They've used it for 2 years, 3 shifts a day. They run hundreds of samples every day. And our customers are kind of varied, but yeah, we're agnostic. If you're doing rubber testing, tensile testing, we can sell you a product. We can do some low force plastics, so we're working with some 3D printing companies in the same systems. But really, we're agnostic. If you're testing and you're doing certain tensile tear, something around that space, we can test for you, kind of thing.
Oh, that's good. As Peram was telling, from Indian perspective, I can tell, yes, you can give an effort. There are a large number of various types of players are there within the rubber industry, from very small, medium, and also tire companies are also there. So this IRC is there, Indian International Rubber Conference, which is going to be held in these things in November.
Yep.
So that will be a good one. If you can showcase your things, people will be in fact even get in touch with you for those things. So when I was actually Piram invited me for this panelist, I was also looking into what automations you are this thing going to talk. So it's you actually, yes, this is a topic which is going to come when we talked about automations, which is coming in the industry, in the laboratory also. So there are a big actually space. One thing you talked about UTM, the rheology segments are also there. People are talking about the abrasion tests, laboratory abrasion tests. It's kind of a robotic things they are bringing into it. And when you talk about rubber industry, not just only physical testings, there are analytical chemical testings are also there. There are thermal systems are there, GCMAS all systems are there. So a whole lot of things are there, bringing automatic and your robotic systems are coming. So thing going on. You are getting into.
Sorry about that. That's fire alarm tests. I'll just mute for a second.
Okay. So things is you are coming into with your UTM coupled with your automated system. That's good. One can look into those who are especially in the product regular production. Fine. So
okay. Dr. Brendan is here. Welcome back,
yes.
Brendan.
Yeah, hey, sorry for having to drop off there. 2 things going on here. My air conditioning system in Central Texas, which we need desperately, is not working very well. And then an attorney needed to talk with me urgently, so I got the attorney handled. We'll see about the AC. So
okay,
anyway,
just introduce you, Dr. Brendan. You already know Dr. Barun. He's from Hasatri. Okay, and yeah. And Dr. Brendan, he worked for the, he retired from ExxonMobil and he worked for a long time there. Okay, so well experienced. He wrote 2 famous books. Okay, rubber compounding, 1 book on there, and then also the tire engineering. Dr. Brendan, would you like to pose any questions to the Richard or Khaled?
Oh yeah, no, I thought the presentations were excellent. and you really hit on some of the big issues that I've seen in labs. Certainly labs need to be automated more. We got a long ways to go in terms of automation, and some of the operations have tended to be difficult to do that, like certainly the raw materials handling and the weigh ups is very labor intensive at the moment. From what I've seen in terms of the testing, it's easy to do the tensile test, Shore hardness, the rebound, and maybe sometimes the tear, the ASTM tear test, that's fine, but adhesion, we're looking at sample to sample adhesion, mounting those on the grips of the tensile tester is not easy, even for labor, let alone the robot. But certain progress has been made there, but then there's other testing like the DMTA work has proved to be elusive so far. And then when you try all that together, the limb system is, to be very candid and frank, I've never seen a good limb system anywhere, period. It's always had issues, that be in the interface or ease of operation or whatever. So Alpha Technologies has got a good one, the Enterprise, but that's been about the best that's in the public domain that you can buy. Other folks have got their own proprietary systems, but that's always been a challenge anyway. But I think you hit a lot of the key points. The limb system, and then the data. How do you handle all that data? What interested me about this particular session is that the ideal would be get to a situation where you've got something like or mimic the combinatorial chemistry types of operations that's used in the pharmaceutical industry. Things like the COVID vaccine could never have been developed as quickly without the combinatorial type of tools that they've got available. So you think like 30 years ago, it would have been impossible to develop those vaccines as quickly as they did. So if you can mimic something like that in the rubber industry, that's going to be a real game changer, real game changer. And then the other big issue I've found is when you do try to automate, the demographics of the workforce changes. So you need an awful lot more skilled technicians as opposed to associate level degree technicians. You look at master's degree level technicians to come in there, and that's so the demographics change certainly. The skill sets will change, but yeah, coming back to I thought the presentations were excellent, and it's certainly the tools that you're looking at are going to move the game forward. That's for sure.
Yeah, we have some questions from the audience. Let me show on the screen, Richard, for you.
Short answer is yes. We can integrate with machines. Problem is a lot of these machines are offline. As you guys know, a lot of testing equipment is just by nature offline. But what we do is we work with a company's internal IT team to work on a data dump from those pieces of equipment to some sort of shared folder. And through an SFTP, we pull that data into the Uncountable platform. So I know a big theme of today has been lab automation. And that's what we try to promote, is that we do have your traditional LIMS features. So you can parse and summarize raw data files from pieces of equipment through a simple drag and drop into the Uncountable platform. But the version 2 of that is utilizing this method of data dump into a folder, and through this SFTP, automatically pulling that data into the Uncountable platform and then mapping it to the appropriate formulations. And we can do this at whatever cadence the team deems is appropriate, every 24 hours, every 4 hours, every 1 hour, every 10 minutes, whatever works most appropriately for an organization.
Thanks, Richard. There is a question for Khaled.
I was waiting for the thing to stop the emergency thing to stop talking.
Okay, and also, okay, fine.
What is the system which can collaborate with endurance testing laws and existing testing machines? I don't know what they mean by integration. If they mean in terms of like the software data dump or what specifically they're kind of getting at here. But yeah, we currently do integrate, similar to what Richard said. We actually do data dumps directly into either central database systems, into Alpha Technologies enterprise system that Dr. Brendan brought up, which is a system that we find a lot of customers are currently using. So it's very easy for us. I mean, we have an open API. My goal isn't to hold on and hoard the data. It's to improve the process in the lab, whichever way we can. So yeah, it's pretty easy to integrate. And we already do it with a lot of customers.
There's one more here.
Online checking for suspension bushings. What kind of testing? I mean, I would ask what kind of testing they do for suspension bushings today. If you guys know Dr. Baroum maybe or Dr. Brendan, what are the common suspension bushings testings? I'm not too aware of them.
Something on an oscillation test.
Perhaps an oscillation test, yeah.
High frequency oscillation. I'm thinking.
Is that
vibration analysis?
I think the best thing I could say here is if whoever wrote this, if they want to email me with specifics for their tests, we can kind of explore it for sure. We do have some people that do online checks or inline manufacturing checking with our system along the way to kind of obviously catch things earlier. So there's a bit of flexibility in there. Dr. Brendan, I actually wanted to bring up, I don't know, Richard, something that you brought up, Dr. Brendan, which is it changes the demographic of who you hire, I guess, as you automate, as you change. And I think what you're bringing up is that it's changing to more of like a tech-focused company versus a chemistry-based rubber production company, right?
Yeah. Well, what I find is that, how do you say this? The technicians that are in the lab are typically associate degree level.
Yep.
1 year college, 2 year college, done very well at high school, that sort of thing. So that's traditionally what you've had. When you move to a more automated facility, then one needs to set aside a group of maybe 5 or 6 people, depending on the size of the lab, that will basically calibrate the new equipment, make sure it continues to run okay. The new test method development becomes an issue. So you end up with more graduate, master's level type of technician in the lab. And there'll be like a small technology support group of maybe 15% of the total lab workforce making up that group. And that way they keep everything running. They'll handle the commissioning of new equipment, make sure the interfaces work out. That last question alluded to, vibration, suspension bushings. A lot of that equipment is offline. But how do you interface that? You need the right type of labor force to, the demographics to basically handle that type of work.
I found large corporations are already doing that in a lot of capacity, right? Like when we, I don't know, ExxonMobil, for example, comes to mind. They started a data team internally, and now they're like 25, 30 people just for data processing. I don't know if you've seen that, Richard. I think the effect is more that smaller, medium-sized companies will have to lean on their external suppliers to kind of bring that expertise. Have you seen that kind of succeed out there, or do you find that generally, eventually, you have to bring some kind of capability in-house for this to be successful?
You got to have it in-house, and even there in-house, the weak link is still the interface between the equipment and the computer systems at the company house, of the SAP or whatever. Certainly everyone wants to hook into SAP or some sort of enterprise system. But that interface always proves to be the weak link. Certainly at ExxonMobil, that was the weak link, was the interface.
And is that only fixable by the companies themselves internally, you think, or is that where something like Richard's interesting software?
My experience, it has to be done internally. which that's my experience. Now, of course, everyone's different.
So what we found is that you made a good comment that LIM solutions, there's not a good one, to be honest. It's why we position ourselves a bit differently, is because they are an archaic software. They have been around since the 80s and they haven't really changed since the 80s. And that's a real big problem of the software landscape for R&D organizations. So what we're seeing today is a pretty big shift, is that people are looking to move away from their LIM solutions because they're either outdated or cost too much to have integrated company-wide. So what we've tried to provide is a more flexible tool that doesn't require what you typically see in R&D organizations, which is a LIMS admin, is one professional who's the one who's tasked to edit this for the entire organization. Whereas we just made it so that the interface is adjustable by the actual R&D organizations. So creation of a new test, test method, doing internal calculations, and just making it so that the tool can grow with the R&D team. And I just wanted to say you made a great point. The software landscape in R&D teams has been stagnant for quite some time.
Yeah. Well, the enterprise alpha enterprise system is about the best that's out there. Although I have to say now, some of the tire companies have developed their own internal systems which perform very, very well. But some are probably better than enterprise. But off the shelf for a smaller lab, that's about it.
But Richard,
I would go so. Sorry, go ahead, Dr. Byrne. I was just going to say, I would gander a guess that that's the kind of problem we're going into, though, in the rubber industry generally, is each person kind of tries to be their little island. And I think it's the same thing with the AI work that happened in the data repository that isn't collected. And then you have these kind of, and we see this all the time with these disconnected systems that get produced. I don't know what the solution is. I don't know if it's rubber specific or if it's across. I've seen it a little bit less in plastics, I would say, as we kind of start to dive in that direction.
Yeah, certainly plastics are simpler. When you have rubber formulations, sometimes with 15 to 20 ingredients, depending on the complexity of the formulation, then it's you end up with a different, again, different level of complexity versus a plastic with maybe just a coloring agent or some other minor additives. But it's rubber's certainly different.
We found that people are also moving away from internal builds as well. We're working with, I want to say, a handful of the top 10 chemical companies in the world in terms of size. And the way we were able to kind of win those out was just honestly them piloting on us for a year's time and doing, in a lot of cases, head-to-head competition versus what they can build internally. And we didn't know that was the task at the moment. We thought we just had a great opportunity with a great small team, a good starting point. But that's what they're looking for. They're understanding that the internal builds just take too much time to get to the point where they need it to be today. And what they're trying to do is they're trying to accelerate their, say, a data science initiative, because Khaled talked about a good point, is that you can have the best machine learning models in the market, but if you have bad data, you have bad data. So what we're trying to do these days is we're trying to not step in as your data scientist or this predictive tools in these cases of these larger organizations, is like, let us complement your teams. Let us put the system in place that you guys can pull from. And that's what we tried to accomplish today.
Richard, I just want to make a comment. When you talk about LIM systems, it's hope you'll agree that each organization's having its own requirement. It's a tailor-made kind of a thing. So a common kind of a software and require or whatever the offer, a single kind of an offer may not serve the purpose for common all the customers. So so here for your product, definitely one need to work based on the specific customer's needs. After all, you see, this is kind of a secondary data kind of a thing. You have to integrate with the machine data capturing systems, and it not just one machines. The LIM systems is for the entire laboratory, and it deals with so many kinds of instruments.
So
So
A couple
that's
good comments there is that you mentioned a lot of different instruments, and that's completely true, is that there's a lot of different instruments used across all these different industries we work with. That's why we built our data uploader tool, or the way that's able to parse these machine generated files. We built it not specific to pieces of equipment, but we built it so that it is flexible and can work with most file types. So the way the logic is built today is that rather we say that we have a connection to your Zwick machine, you just literally drag and drop your files to the platform, and you're the ones who are able to write the logic into the system. Say, I want this to calculate the peak of the curve or the area under curve, or pull this across 10 different replicates. And you can do so because we didn't make this specific to pieces of equipment, but flexible to read different types of files to help you parse these different type of files. And the comment you made about different needs across different industries, that was a challenge from the start, and it's continued to be a challenge today, to be quite honest. You saw some of those companies we work with span not only in rubber, but to paints and pigments, to 3D printing, to glass, to foam. But all these different edge cases that we find ourselves getting into, from our traditional chemicals and materials companies to companies that are completely different spaces. We work with Ripple Foods, which is maker of this this pea-based protein, or we work with St. Jude's Structural Biological Department, or we work with pharmaceutical companies. And by us kind of jumping into these different industries, learning about what people need, it makes so that our platform is more and more flexible. So whereas in before, we'd have to come to these organizations and do a lot of hard coding into the system to get it up and running for these teams. But being that we have the experience with all these different industries, the system just becomes more and more flexible as time goes by.
Hey, well, let me ask a question. When it comes to workforce demographics, have you noticed your clients having to set aside dedicated or create dedicated teams to work with you? Or does your system just integrate seamlessly into the client's operations?
For us, I guess I'll speak for us. It's just there's nothing for them to add in. If anything, it's it's a fully in-housed, easy to use kind of system, so it's integrated like a computer pretty much. And then we have a software team that integrates into the whatever software needs that exist there. And that's pretty much it from our end. So it's pretty easy plug and play kind of concept.
Okay.
Yeah.
Same over here too. I mean, of course, there's the inertia that comes along with moving people away from spreadsheets, which is natural, because how has everyone been working for the last few decades? That's of course something that comes along with pretty hands-on configuration, implementation, and training process. But we do attempt to empower people to make these adjustments on your own. Like I said, the platform is configurable so that you don't need a LIMS admin. 85 or probably 90% of the changes can be made by a scientist, and we teach people how to make these changes. So this is can be adjusted as a team needs, but doesn't require any kind of specific like IT background or very strong tech savvy type person.
Okay.
I genuinely find, just as a side note, like when it comes to adding in automation or new tech people or whatever, the detail is in my opinion, is tackling the big problems first. And I think what I find with a lot of labs we walk into is all of a sudden they want to solve all the problems. I don't know if you see this, Richard. And so things will come out from the fringes that they usually rarely do, and they'll be like, no, but we needed this added or this added. And I think that's where the complexity starts to kick in, when you start to do everything, right? Yeah. And I think there's low-hanging fruits out there where you can improve labs dramatically, even from, I think, Richard's point, which is like, literally sometimes they're just writing on paper and putting it in a folder. Maybe there's a better way to do that and a much easier way to do that. So I think the best way to move forward is to solve the big problems and then slowly trickle down into the weird fringe problems that every single customer, every single person has in every plant.
Okay. We're still young enough so that we do a lot of these changes that people ask for. So this is how it was actually driven our platform to where it is today, is that a customer asks for something, we think to ourselves, can this be deployed to our general platform? Can it be beneficial to customers in the same industry or adjacent industries? And if this is a yes answer, then we build it into our platform. So I do assume when we get to the lab vantage size where you have over 1,000 customers, then we won't be making these changes as often as we are today. But I think that's what's been helping us kind of become, like I say, a more comprehensive tool. It's just being willing to add in all these different kind of feature sets and workflows and just flexibility into the tool.
Yeah.
No.
Okay.
For hardware, that's hard. That's the thing we had to really put our foot down on some things where it was, because otherwise hardware becomes really expensive. As you guys, like, if you've looked at automated hardware systems that exist from other people, they're expensive because their goal is to integrate everything in all of a sudden, right? And so that expense, goes through the roof, and therefore they become really unattainable. And so from a hardware perspective, it's about tackling the most important things first, and the highest volume things, the most important test results first, and then moving forward into things that are very low volume that are done maybe once a month or whatever it is.
Richard, when you say your software, there are companies, laboratories, where they have multiple kinds of laboratories. There are physical laboratories, there are analytical, there are chemicals, there are environmentals. So how expect to that kind of a complexity, the software which you are presenting us, how fits in that requirement?
Yeah, at the very top, we separate these different groups, departments, material families, whatever you want to call it, so that their individual groups can convey or their different groups are specific to those needs of those analytical team versus team A, team B, team C. So we do have the hierarchy built so that you can have these separate teams as unique entities, but you can have interactions between group to group within the same database. So it is not just one big pool of, hey, all of my tests across an organization, they're specific to these groups at the very top so that we can have the uniqueness that is needed for these individual groups across an R&D team.
Do you have your website, which is kind of demonstrating all those things? Because the subject matter is quite complex and I know lots of queries will be there in the customers' minds. So
yeah, definitely.
Your website explains.
Our website does an average job at explaining things. It's actually under construction right now. But what I can do is I can provide some additional information, like some videos and case studies. We have a case study we did with Cooper Standard that I think is probably most relevant for all these people in the Rubber Talk today, and also some kind of high-level marketing videos as well. But yeah, our website should be changed, I want to say within a month, but we're all kind of collaborating on what's most important to put in the new website V8 or wherever we are at today.
I think that is the key thing today. Through that media, potential customers can look into and see how much suitability is. Same thing I will say with Khalid also. It will be good to have, I think you have your websites with that UTM based things. So that will be good. You can provide through Peram. He has such a huge network through which we can see all those things. That will be a good, useful thing.
Hey, Khalid and Richard, I have some general questions for you.
I can go. I can first. So, first question is, what kind of challenges have you experienced in implementing this solution with current clients? Those first challenges, like I said, is overcoming this concept of change management. We're asking about a very tall task here. Replacing a LIMS solution is one thing, but getting people to formulate in something that's not spreadsheets is quite challenging. So what it does require, and what we haven't been able to move away from just yet, which is probably beneficial to our customers, is a lot of hand-holding. So this means that we are working side by side with these scientists to not only understand their needs, but teach them how to use the system for their specific use cases, and make sure that that the system does look and feel, and there's no reason to go back to their favorite spreadsheet that they've been using for the last decade. Khalid, do you want to just do these one by one, and then we can, or should I just do across the board? Just do one by one.
I guess we'll do one. Yeah, let's just wait for they're doing testing all day here about this fire alarm thing. Okay, so what kind of challenges? I think similar, pretty similar, I would say. For us, it's whenever you're introducing a new technology or a new way of doing something, and being new in that, something that's already pretty established, I find it's a bit of a uphill battle in terms of obviously proof of concept. You have to bring the product. For us, it's about data and proving the data itself. And then something that Dr. Brendan kind of brought up, which is it actually easy to use? Like, do they have to change the systems and, you know, we have to go through that process of, are you changing the way you do things, or are we just improving the way you do things? So those two questions start to come up. So you're really just going through that. So I think the main challenge is it's a really, it's an industry that's kind of set in its ways in a lot of things, and it's just kind of trying to change that mindset and move it forward. I think that's the biggest challenge we find.
Time frame suggestions in lab automation. I'm not really sure what this is suggesting. Is this I guess I could say we'll call this implementation of Uncountable versus the implementation of Labs Cubed. So for us, it takes about 4 to 8 weeks to get people up and running and using it. To get more towards lab automation, where we're automatically pulling data into the platform, this is probably like version 2, because version 1 is how do we get people out of simply spreadsheets. Version 2 is how do we automate data dumps into the Uncountable platform. That typically comes between, I want to say, month 6 and month 9. But key thing is how do we get people using the system as soon as possible. So it's a gradual process.
Sorry, again.
I can keep answering the questions as he's got the beeping on in the background. It's no worries.
He just finished. I got 2 seconds.
Go ahead.
I don't know. I don't know, Richard. Like, in terms of implementing for us automation, I mean, the machine is shipped, it's put on the table, you plug it in. There's no pneumatics or anything. It's just one plug like a computer. You're trained in like 15, 20 minutes and you're good to go. So I think that maybe time frame in terms of suggesting when to start implementing automation for customers. I would say as soon as you find a need. Find the most important thing in your lab, whether it's the software or hardware that gives you a great return, that proves out the concept of automation, that brings benefits to you, and start somewhere. Start small and build out. Don't try to solve everything at the same time, I would say, as well. That's a big problem that we see with people. They go for all of it and it usually fails because it's too much to take at once. But
yeah. What to be prepared in SME before implementing automation? I'm assuming small, medium enterprises is what we're talking about SME here. The thing to be prepared is just to kind of, let's think, I would say making this a top-down approach, I think is the most important thing to be prepared of, is that without having this as a top-down approach and giving people the outs of potentially using their current tool that they're using today, you won't ever be able to invoke this change. But if you make it so that everything is from an Uncountable standpoint, you say, okay, all of your projects need to be done in the Uncountable platform, and upon completion, your reports have to be created in the Uncountable platform. All your testing has to be recorded in here. All your lab requests have to be recorded in here. With making this a top-down approach and making this mandatory, you can help kind of push this change along faster, versus if this is an optional thing to use, then we'll go years and years with people still using the same tool today, because why make a change if it's going to be a little bit more challenging for them to naturally learn and pick up on a new tool?
Not sure. I don't have anything to add to that, Richard. I think you did a great job on that. Yeah. Last one's yours as well.
Cloud storage guidelines. So we only work with R&D teams, which means we manage a lot of intellectual property, and we really do understand the seriousness of protecting our customers' data. So I can tell you till I'm blue in the face how much effort we go in terms of data security procedures, but this is like, we receive a SOC 2 Type 2. We do annual penetration tests. But what it does require is a sit down with each company's IT security team, and for them to say, these are our requirements, and for us to tell you how we're going to meet you and meet these requirements. That's a necessary part of the process, but we do expect this as part of the process because this is such a critical piece, because we're talking about the crown jewels of the organization. We understand that.
Okay, that's the questions we have. Would like to add anything, Khaled?
I was just going to say, I think that security question is going to be an endless uphill battle, no matter how you slice it. We hear it everywhere.
Sure.
because we do a lot of remote maintenance on the system, so everything's done over, so we can turn on sensors, cameras, see what's happening if something needs to be fixed. So we don't have to have technicians go in. We do software updates over the air. We work with military companies. We work with R&D companies, just the same. I think it's the same question that comes up, and in the end, it's going to be, like Richard said, proving out the security is a big point, and proving that it is a secure system. And I mean, it's the same system that they're using now for banking, for example, like, you know, governments are using it. And the other one is there's do the benefits eventually outweigh the risk? And I think once you have that proof point, then people are kind of forced into it no matter what happens. But I think we just need to show the benefits, really.
So you guys talk about a little bit of cost information implementing.
In terms of what, sorry?
You know, if somebody want to invest in this lab automation, what kind of costs involved? That's the labs cube, you're Uncountable.
I'll be the guy to keep that cost in my back pocket. If you are interested in evaluating this further and discussing costs, well, I can discuss what the cost would be like for individual R&D organizations, but it'll require for you to reach out to me. I want to leave that carrot, so hopefully some people will get in touch with me after this call today.
Okay, sure.
Yeah, I mean, I would say the only thing I'd say for us is we've essentially aimed at, and Dr. Barun and Dr. Brennan, you guys will know, like any pricing around Zwick or Instron, if you guys have bought a manual system, we're pretty much placed around the same price point. And our goal there was to make automation attainable for everyone. So we really haven't gone crazy. I think a lot of automated systems out there, you know, start to hit into the $500,000 plus. We're nowhere near that because I don't think that's attainable for most anybody really. That kind of puts it out there. So yeah, but yeah, pricing I think is a big question for sure in terms of automation, and that's a question that always comes up: is it too expensive? Is it worthwhile? Does it actually save me money?
Yeah.
When do I get a return on that investment? That question comes up a lot for sure.
I'm sure that Dr. Barun would like to ask that question, right?
Yeah, obviously it will be coming onto that price. But I would like to really look into in details in your website on the things. Of course, what Peram is telling cost coming into will be, but before that, I would say the technical things comes the first to whether it is first of all meeting my requirement or not. So that's the thing is the first. Is it going to serve my purpose? It is going to benefit us over my existing system. As Richard was also telling, that point is very, very crucial today. Everybody will be having some systems. For example, LIM system is there. So how those go, my past data is going to be, if I find this new system is going to be a huge benefit to us, how the integration is going to happen. So all these are as a big questions in the minds of everybody. So definitely website is going to be one of the big platform for both of you, where one can get into details of it.
Yeah, no, I find with us, you're right. It's all a proof of value, right? Like, what is the actual value in
exactly
cost aside, etc. Is there an actual value in putting this in,
yes.
and does it change things for the better? So that's the first thing we do. We always do proof of value with people, and if it doesn't make sense, it doesn't make sense. Like, not everybody's going to be the right person for every product.
Right. Absolutely.
And I think it's really important to figure that out as early as possible and have that honest conversation.
Absolutely.
Yeah.
Dr. Brendan, you'd like to add any points or you'd like to ask any further questions to these two gentlemen?
No, like I said, this has been very helpful, and I apologize for having to drop off a couple of times there for the AC system. But anyways, I think part of there's three big issues around IT systems in the lab, pretty much center around irritating things, like for example, quality. In the old system, transcribing, it's unbelievable the number of errors that occur when technicians have to transcribe data from a tensile tester into a Excel file or whatever. The other one is data retention. There's some big benefits there in terms of data retention, and which is in the entire industry is certainly very important. And the third thing is collaboration. Data sets like this allow much higher level of collaboration, which Richard had mentioned between Europe, North America, and Asia. That's the way business is going, collaborating between the regional labs. So between data retention, collaboration, and quality. They're the three big things that this, these types of tools allow us to move forward with. So again, they're great presentations. Thank you.
Thank you, Dr. Barun. Dr. Barun, please.
Yeah, I think we have talked to a good extent. I have nothing to add further on this.
Okay, thank you, Dr. Barun. Khalid, final remarks to the audience.
Final remarks. I think you have to look at your own labs, your own systems, and see where you can make big improvements. I think there's low-hanging fruit for everyone to make those improvements, and then time it just right and figure out and see what's out there. Things are always changing, and hopefully there's new technology coming along, whether it's us or other people bringing in amazing new technology to the rubber industry. So yeah, I'd say let's keep pushing the rubber industry forward faster, because I think that's when we make really big positive changes, hopefully.
Super. Thanks, Khalid. Richard, please.
Yeah, I think I made a lot of remarks about, accelerating development. That's a really big buzzword at the end of the day. Everybody's trying to accelerate development. I completely understand that. What I want to say that I think resonates with all teams is that the reason for making the switch to, like, say, a new modern R&D software solution is the fact of the matter in the rubber industry, or across a lot of R&D organizations, is a lot of senior talents retiring. So people are seeing that their senior scientists over the next 3 to 5 years are going to retire. And the concern is that all of this organizational know-how that they've gathered over the last few decades is going to walk out the door with them. You're not going to be able to look through your LIMS system. You're not going to be able to look through your ELN or your spreadsheets. It's literally going to be lost. So the ramp up of all of these new scientists that you're looking to replace current talent today is going to take quite a bit of time, because there's no good way of kind of, like I said, capturing everything they've learned over the span of them being at your organization for quite some time. So it's better to act now, because this is something that is happening now and happening very soon as well.
Yes, you mentioned truth, hard truth, man. Yeah, guys, thank you very much for joining this session. It's very enjoyable, very informative. I thank Dr. Brendan, Dr. Barun, and Khalid and Richard for being part of this rubber testing laboratory automation. I hope you enjoy this session too, guys. Thank you very much. Appreciate the time for being part of this rubber industry tech talk on the rubber testing laboratory automation.
Thank you, everyone. Bye.
Thank you, guys. Bye.
Thank you, guys. Thank you.
Thank you.
Okay, that's the end of this episode of the Rubber Industry News Hour. I'm hoping that you find this session useful, and you can always watch this full episode on YouTube at the TechnoBiz channel. Feel free to check it out. And I see you in the next episode. Thank you all for joining this session today.